In this video, I'm going to teach you how to calculate each branch current in a parallel conductive circuit as shown above, and how to calculate the potential difference between 2 points. Now, for you to solve this question correctly, there are certain principles and rules you need to understand. Now, the first one is for you to understand that in a parallel conductive circuit, the equivalent conductance is the sum of the individual conductances. And also note that in a parallel circuit, the current divides. That is, different currents flows through each branch, as you have seen, I1, I2, and I3 as well. Then now, considering this circuit above, you can see that we have two sources of currents. This 25 ampere source and 6 ampere source. And these two currents are flowing in the opposite direction. Then as such, we are going to calculate the net currents, that's the total current in the circuit. Since they are flowing in opposite directions, we take the difference. Then as such, the total current IT equals 25 amperes minus 6 amperes, and this gives us 19 amperes. This enables us to draw out the second circuit as you have seen above. Now you have shut one of the current source out, then to working with one, which is the net or with the total source of current here, and we have the individual conductances as it was before in the first circuit. Now the first question is for us to calculate the each branch currents. Now the first parameter you need before you can do this is for you to calculate the combined conductance or the equivalent conductance in the circuit. Then, as I said earlier, that the equivalent conductance G in a circuit is the sum of the individual conductances. That is, G equals G1 plus G2 plus G3. Then as such, you have that the total conductance in the circuit equals, since they are connected in parallel, equals 0.5 Siemens plus 0.2 Siemens, 25 Siemens plus 0.2 Siemens. If we sum this out, you are going to have that the equivalent capacitance, the conductance in the circuit equals 0.95 Siemens. Now you have gotten the first parameter. Now the second is for us to calculate the current in each branch. Now for it to get I1, you're going to use the relation that says that I1 equals I total multiplied by G1 divided by G total. Now I1 equals total current in the circuit. You can use T or you can leave it. Equals 19 multiplied by G1 is 0.5 divided by G total, equivalent conductance is 0.95. Now, if we simplify this out, you are going to have that I1 equals 10 amperes. Then now, to get I2, you still follow the same approach, that I2 is denoted by the relation I total multiplied by G2 divided by G total. Then now you have that I2 equals 19, which is total current, multiplied by 0.25 divided by 0.95. We move to this side of the board. Then if we simplify this out, you have that I2 equals 4.99 amperes, or I2 equals 5 amperes approximate. Then to get I3, you still follow the same approach that I3 equals I total multiplied by G3 divided by G total. Then we have that I3 equals I total is 19 multiplied by G3 is 0.2 divided by 0.95. Then as such, if you simplify this out, you have that I3 equals 4 amperes approximate. Therefore, we have in summary that I1 equals 10 amperes, then I2 equals 5 amperes, and I3 equals 4 amperes. And these are the values of each branch current as was required. Now, the next question is for us to calculate the potential difference between point A and B. Now, you need to know that, as I said earlier, that in a parallel circuit, the same voltage flows through while current divides. And this was the reasons we were able to get each branch current as was required. But the potential difference, all these branch are at the same potential difference. Then as such, only one source of voltage flows through the whole branch of the circuit network as shown above. Then for you to do that, if you are able to find the potential difference at any point, that is the potential difference for the whole circuit. Then now, the first parameter you need to obtain is for us to obtain the equivalent resistance in the circuit. Now, the equivalent resistance for the circuit, that is RAB equals 1 divided by GAB. That is the total resistance, or resistance equals the reciprocal of the conductance. This is what this means. Then we have gotten our equivalent conductance. Then now to get the equivalence or the combined resistance in the circuit is equals 1 divided by the equivalent or the combined conductance. Then now our for instance, to get R1, that is resistance 1, we have that we are going to have here that R1 equals 1 divided by G1. Then if you can be able to get the value of R1, you are going to be able to get the values of the potential difference. Then now I1 was given as R1 equals 1 divided by 0.5 here. Then now, if you simplify this out, you are going to have that R1 equals 2 ohms. Then since you have gotten the value of R1, then note that potential difference at any point, potential difference VAB equals I1 multiplied by R1. We have gotten our value of I1, which was 10 amperes. Then now we have gotten the value of R1, which is 2 amperes. Then as such, the potential difference AB will be given as VAB equals 10 multiplied by 2. Then as such, VAB equals 20 volts. That is the potential difference between point A and B. Don't forget to subscribe to my YouTube channel for more math solutions. See you in the next video.